Supposedly our parents were supposed to be on the whole life skills thing.
Yeah.
Whatever.
No big deal.
Alright, we'll see where that goes. Alright, hopefully these markers are in decent shape. Today is April 15th. That will be a day, as you get older, you'll start to care about more and more, as today's the day everyone's taxes are due. Alright, Joey, do you have a physical packet? I know I put one on top of your backpack at some point.
If not, we can just do number 9.
We'll jump to number 9, that's fine. What's the page number on that?
294.
294.
100% sure I had it.
Joey.
Alright, then we can. Okay. Number 9 says, consider the function, and it's a piecewise function.
Totally forget how to do this.
It all goes back to those first principles, ideally. What is a derivative? What is, okay, so, the function is 2x squared minus x cubed.
And the second one is e to the 2x minus 4. Now should we?
Minus 4?
Yeah.
Minus 4 is
Oh, minus 4 is up in the x
yeah,
now.
sorry.
Okay, and what's the boundary between them? When does it stop being one and start being the other?
X is less than 2 and x is greater than 2.
Okay, and the question
Should we
is,
derive each one?
well, the question is, what is the limit as x approaches 2?
Can we derive each of them and plug into or?
That would be talking about differentiability rather than continuity. This is a kind of a continuity question. This is back to when we first did limits. The first thing you always do when you're faced with a limit, if you don't see a delta x. If you see a delta x, you're looking at the limit definition of the derivative. That's pretty much the only application of that on this exam. If you see an x, you're just talking about a point along the function. So all you do is plug, what is f of 2? Well, I'll put it this way. What's the limit as we approach 2 from the left of f of x? The first thing you do is you plug in.
2.
Yep. So, and then we get minus 2 cubed, and we are going to get 8 minus 8, right?
So you can keep, okay, because I plugged in 0 and thought it was kind of like when you get 0 over 0, you have to keep going.
Oh, no.
So
You're
it's
mixing up.
okay to keep it as 0.
0 is a totally fine answer. Actually, remember, 0 is fine, undefined is fine. Indeterminate form, 0 over 0, is the only one that requires you to even think deeply about it. Now, as we come from the right towards 2, what is e to the 2 times 2 minus 4? Well, that's e to the 0, right? Which is 1. So does the limit as we approach from the right equal the limit as we approach from the left?
No.
No. Does the limit exist?
No.
Boom, that's it. Plug it in. So since they're not equal to each other, that's e, I think, which is the limit does not exist. That's actually a problem you could have done last May at the end of pre-calculus when we first talked about limits. But we've talked about so much since, I get why.
It's been pushed down to our ears.
Pretty much.
There's stuff that's been pushed in.
It's like a Play-Doh fun factory at this point.
We do 14. I know you gave us a hint on it, but I still couldn't get it.
Says, take a look at yours. Okay, so 15 says, the derivative of the integral. And it's the integral from what to what?
The integral from 2 to 2x.
2 to 2x, okay.
It's the cubed root of 1 plus t.
That's not a fraction?
No, so
Okay, that was my fault for presuming. Cube root of 1 plus t dt. Okay, if this were just a number to x, or 0 to x, how hard would this one be?
not this hard.
I'm sorry, the integral and the derivative would just cancel each other out. But I said you have to be careful when there's actually anything other
So
than
if
x up
it
here.
was 0 to x, the big one.
Yeah. Boom, 0 to x just cancels and you're left with the function. But in this case, it's so close. You can basically plug it in, except there's a,
How do you do the u and d?
well, this isn't really sort of a u substitution. Well, it's a u, u is 2x, right? So du, our
Wait,
limit.
how is U two?
Well, in this case, this is the second fundamental theorem of calculus, which basically says these cancel each other out as long as it's a constant to x. Okay? But when you have a function up here other than x, you have to take the chain rule into account.
Is there a better way to do this?
Yeah, it's actually just t is going to be replaced by the 2x.
Yeah. What about the two?
And then we have to put a 2 in. Because we have to take the derivative of whatever function's up here. So instead of just replacing t with x, we replace t with 2x, and we put in a derivative of 2x. And I believe that's one of your choices. I think the 2's in the front. And isn't that choice C? Let me do another example of this just to get the pattern, because I don't think I explained that well. Let's say it was the integral from 1 to sine theta to sine t. Actually, I'll say sine x, to be consistent, of t squared dt, and that was being derived. Okay? What would t turn into? Okay? So we know this with the integral and the derivative are going to cancel out. So we're not actually going to do anything. We're going to wind up with this function again. But what does t becomes sine x? So that's sine x squared. If t is sine x, what's the derivative of t? Yep.
Which is weird, I've never seen it before.
We did it very briefly. And I don't think I explained it particularly well. So that's what happened here. Derivative and the integral cancel out. The t becomes the 2x. The dt becomes the 2. In fact, probably be less confusing if I more clear if I use t's instead of use the. Joe, you got any questions on that one? Okay, so that's number 15. Do you want to do 16 next? All right. Did I only assign 1 through 14 this time?
Yeah, but.
All right, did you have any questions from 1 through 14, just to have this be more for, see, I mean, in case that's what.
Yeah, those are my questions for 1 through 14.
Okay.
Do you have any, Joey?
You felt good on the other ones? Because we can keep rolling through them, that would be good. Page 292 again? All right. Yeah, let's check your answers real quick. And we're on again. Okay, so number 2 says, find the average value of the function, and they give a function that's 2 lines. It's another piece function, right? It's on the interval -1 to 4. Peaks at 1, 2. Is that about right?
Oh wait, was it B, the answer?
I'm not sure now. Let me check. This was number 2? Yes, the answer is B.
Okay, I know what I did wrong.
All right, well, just to check, you know that the average value of f of x is the integral from -1 to 4 of f of x over 4 minus -1, right?
We did 1 over B minus A times, did we do that?
It's the same times the integral.
No, actually, I
times
think
the area.
we just added the, we just added the area to 2.
And divided by 5. Because the average value is supposed to be the integral. Oh wait, I made a mistake. This hits at 3. And then it goes down 1 more to 4. Looking like it lines up with -1. Alright, so what's the area?
Yeah, it's divided by 5, okay.
Okay, so what are the, because of,
Sorry.
that's alright.
The The area of the two triangles together is 7/2. What I did was I added the two, but you're supposed to subtract the smaller one.
Right.
And then you do 1 over, like,
So there
all
you
of that times 1 over b minus a, so that's like 1/5 times.
Gotcha. So that's 1/2 base times height. This base is 2, this height is 2. And then plus 1/2 base times height. And is that symmetrical? That's another 2 and another 2? Yep. So plus 1/2, 2 times 2 again. And then minus this last triangle, because this is negative area. So that's minus 1/2, 1 times 1, all over 4 minus negative 1. I don't see a particularly faster way to do that. Joey, how am I doing on setting that up? Okay. Half of 4 is 2, plus 2 is 4, minus 1/2, I'm getting 3 1/2 over 5. We don't like mixed fractions like that, or, yeah, compound fractions like that, so I double top and bottom to get 7/10, which I think the answer is B. All right,
Are you 16?
yeah,
Well, it's kind of like
16 is consider the graph. Okay, give me a minute to set that up. We are on the phone. This will take some serious editing. Okay, but my goal was to be able to see this. Lord knows how it'll look on the video. Is that clear? Okay.
tech.
The idea is consider the graph of the function. So this is the original function, and they're just asking about the derivative. This is somewhat reminiscent of those free response questions we looked at, except it should be a lot easier. Okay, couple of possible shortcuts here. What does that shape sort of look like on number 16? What should this make you think of? Cubic, I hope. Parabola, you're skipping ahead a bit, whether you know it or not. It does look like a cubic or possibly a tangent. Now, if it looked like a tangent, you know you should be looking for something that would look like a secant squared, which we haven't talked about much. So that would be annoying. But if it's a cubic, what general shape should its derivative look like? What's the derivative?
Like a
Square.
or no?
If you start with anything cubed, y prime is going to be something squared, right? So which of these looks like parabolas? B, C, and D, and I cut off E from the picture. And I'm not too worried about E. I did cut off E. There was another choice there that I might have to look at. Let me see if it's on the page.
A, because it's so much. Well,
Yeah.
if it's not D, or if it's not E, then you know it's not D. Like.
Okay. Well, let's take a look at this.
It's not gonna be that shift.
Wait, the graph of, let's take a look at this. The graph of f prime will actually describe, the y values on f prime will describe the slopes of tangent lines to the original function.
So that's negative, negative. Or no,
Is that a
no,
positive?
it's positive, positive, it's going up.
And then it does hit 0 there though, right? Cubics do.
And then it's a 0, and then it's positive, positive.
Well, wait a minute, that's only if this really is a cubic. This might not be a cubic as I look at it.
But
This
does
might be a tangent.
well, does it matter either way? Because it's still always positive, right? It
Well-
still switches.
Here's my issue though. The derivative does switch. It does change on whether it's smiling or frowning, doesn't it? Here are positive slopes of tangent lines, right? Okay, here are positive y values. So they describe positive slopes of tangent lines on the original graph. Here's some positive y values. This one hits 0. This hits 1 and has all positive. So the question now becomes, is this really a cubic? I may have spoken a little too quickly. If you look closely at that, let me go back a second. First off, you guys get that this has nothing but positive slopes of tangent lines to it, right? The only question is, does it have a 0 for its tangent line there? Because that would make it a real cubic. Yeah, these two parabolas both are the only things I see that could be describe the slopes of those tangent lines, because these y values are all positive, These y values are all positive except for a 0. Let's take advantage of this high-tech Jen was just describing. So our only real question is, does this look like it goes positive slope of 1, more positive, or positive slope of 0, more positive? Which one does that look like it does through the origin? Really, the slope of 1? The slope is 0, you'd have to see it go to horizontal and then come back up. Does it look like it does that? Okay, that looks to me like they're trying to say, I want you to see, I want you to get any more.
If they want us to do this by sight, then.
It is. It is. Thank you. That looks closer to a slope of 1 to me. So I'm going to go with D. Because D says, I'm going to go with D because D looks like it has positive, less positive, less positive, less positive, y value of 1, positive, positive, positive. And these y values on an F prime graph should correspond to the slopes of tangent lines on your actual graph. Does that make sense?
Wait, so because it's a slope of 1, this one like shifts up 1.
Yeah, because that's a slope of, looks like a slope of 1 in the middle. This D is the only F prime graph that has a y value of 1 above the origin. If I were looking at this F prime graph and trying to graph F, I would say positive slope, less positive slope. Here's the slope getting less positive slope, slope of 1, more positive slope, more positive slope, more positive slope. And that's pretty close to the shape that we are given up here at the top. Correct? Okay. Any questions on that? So I'm going with D.
So like for just the regular F graph of F, you just look at like whether the slopes are positive or negative. And
Yes.
then for the derivative, you just look at whether it's actually in the first or second quadrant.
For the derivative, you look at, if we're working backwards from the derivative, I can line that up again.
No, we're working forwards. Like given the graph of F.
Given the graph of F, okay, the slopes of these tangent lines, given the graph of F, there's a very positive slope of the tangent line, right? And it does correspond, like this very positive 1 would be somewhere down here at -2. Go over to -1, I'm now less positive. Go to 0, it looks like I'm at about 1, but then I start getting more positive as I go. So that's what tells you that the derivative looks something like
Wait,
this.
so because there's another part of the third quadrant.
Okay, down here, it doesn't matter what quadrant the y values are in the original function. It matters what the slope of the tangent line looks like.
Okay.
As I go from left to right, it seems like, all right, Jen, we'll see if I can, how coordinated I am, if I can not block the light. Okay, high positive value, right, for both the slope of the tangent line and where my left hand is. Less positive slope, less positive slope, less positive slope. Now, all of a sudden, we're getting more positive slopes, which means the derivative has to have a higher y value as the original function gets steeper. So our only real question became, what sort of parabola was this? And they gave us two choices. They gave us two real possible choices, I would say, B and D. And on B, this 0 on the derivative function, on the f prime, would mean the original function would have to look like it has an actual 0 tangent line somewhere. And it doesn't. This one, since the y value is 1, this means it only has to look like it tapers off to a slope of 1 before it starts increasing again. This one, you actually have to see it curved horizontal for that to describe it. And you do see that if you look closely enough at a cubic. So I'm not sure what function this is. Probably come up with one. Could be a single repetition of a tangent.
Wait, so because it doesn't look like a zero slope for the original graph, like,
Since it doesn't look like a zero slope for the original graph, it looks like a one slope, the derivative graph should not pass through a y value of zero. If it doesn't,
okay.
see this zero here, the fact that this parabola for f prime, or secant squared it might be, hits the origin, because of that, because it actually has a y value of zero, that means the original function should have a tangent line with a slope of zero at that point. It doesn't look like it. It looks like it has a tangent line with a slope of 1. Because this parabola hits an actual y value, or secant squared, again, I'm not sure. Because this derivative graph, is all I should say, hits an actual y value of 1, the original function should only have a slope of a tangent line of 1. And Joey's right, they're expecting you to go by the visual here. Yeah, it's one case where they're not particularly trying to trick you. Okay. All right, let's take a look at these. Hopefully one of these markers are better. F prime of x equals 2x, x plus 1 times x plus 1 squared. F of x has, okay. You could do this with sign analysis. This might be the most certain way to do it because...
I tried sign analysis, but I got that -2 was minimum.
Okay, well hang on. Let's take a look at 2x then first. So 0, negative, 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 0, positive, 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 right? That's the behavior of 2x. The behavior of x plus 1, we have a 0 at -1, negative, 0, positive, switches at -1, correct? X plus 2 squared, that's relatively simple. 0 at
Is it a 0?
-2, you're correct, I'm wrong. But what does it do everywhere else? Because of the squared, it's just positive,
Oh.
okay?
Okay, let's say that.
So now f prime is interesting at -2, is interesting at -1, is interesting at 0. And below -2, we're looking at a negative times a negative times a positive. That's the sign of my 3 factors, which is going to be positive, correct? 0 at -2. Negative times positive between -1 and 0 gets me negative. 0 at -1. Between -1 and 0, I'm getting, I did not do this quite neatly enough. Actually, wait, I'm getting positive. I'm getting between -2 and -1.
Yeah.
Oh, yeah.
It's still positive. Okay? So we don't have a min or max there because it stays positive to positive. It's negative between -1 and 0, and then from 0 on up, it's all positive, correct?
So we have this at -1, we have a relative max.
Looks like, because if we talk about the original function according to this is increasing
We can eliminate D and
horizontal tangent, still increasing horizontal tangent, this is not very neat, then decreasing
so it's C.
horizontal tangent, then increasing. You're so far ahead of me, kid. I love that. Okay, so the original function goes increasing horizontal tangent, more increase, horizontal tangent, decrease. If you increase horizontal tangent, then decrease, you're looking at a relative max at -1, right? And then if you decrease horizontal tangent, then increase, you're looking at a relative min at 0.
Yes,
And you
it's
say
A.
relative max at -1, relative min at 0, that's what I'm getting. I would bubble in A for that one. All right, any questions on that one? Number 18. I hate all my markers today. That went in fast and at least. 19, yes, finally a good marker. Okay, the area under the graph of y equals 1 over x. Okay,
Okay, I drew the graph.
hold on. Area under a graph should make you think of what?
Integral.
Okay, so they're talking about the integral of 1 over x dx from 1 to something, right?
Yeah.
And they tell you that that something a is greater than 1, so you know you're going to the right, so you don't have to worry about the fact that you're about to hit an asymptote, and you don't have to worry about the fact that if you go the other direction from 1, your integral will switch signs from positive to negative. Okay.
So you can draw it.
You can draw it, but what's the integral of 1 over x dx?
1 over x ln.
So we're looking at the natural log of x from 1 to a, right? Which is natural log of a minus natural log of 1. What's the natural log of 1? E to the what gets you 1? 0. But natural log of a is not a choice, is it? Is equal to the area under the curve. I think I'm misreading this a little too quickly. Is equal to the area under the curve from x equals p, where p is less than 1. Express p in terms of a. Okay, so they're saying go in the other direction. So maybe a drawing is helpful here. So here's what y equals x would be, right? Y equals 1 over x.
Yeah.
Okay?
And then you have
Here's 1. Here's a. And you have some area here, correct? And they want to know if you go to P in the other direction, what will get you the same amount of area? And that's where the negative comes in. Now, since this is going up higher, it doesn't really look like, since this is going up higher, you shouldn't have to go as far in the opposite direction to get the same amount of negative area going from 1 to P as you do positive area from 1 to A. Does that make sense? Okay. So what they're really saying is, all right, this is the area you get going in this direction to A, right?
Wait, what is it? It's ln A.
Just natural log of A. That's that's sort of the definition of that integral. We talked about that when we talked about why E behaves the way it does. So what they're really saying is, bless you, is you're looking at an integral from P to 1 of 1 over x dx, if I'm reading this right, that gets you an area equal to the natural log of A. Do you think I've set that up correctly? Okay, so now we have to solve this. So this says,
Well, 1 over x still becomes ln x.
so that's natural log of x, but now it's from P to 1 going from left to right, and that equals natural log of A. So I'm going to get the natural log of 1 minus natural log of B. Thank you. I was thinking ahead and brain farting a little. Once again, natural log of 1 is 0. Okay, so we're looking at negative natural log of P equals natural log of A. Have we expressed this in terms of A yet? In terms of P yet, excuse me. Have we got P by itself yet? Okay, we don't have the variable P by itself, so we can drop the natural logs as long as there's no coefficients. Remember that? We always had to get rid of coefficients in solving natural log equations.
Yeah.
So negative 1, right? What can you always do with a coefficient with a logarithm?
Oh, push it off.
Very good. So that's P to the negative 1. Which means now I can drop the natural logarithms. P to the negative 1 is 1 over P, which is equal to A. So So I would say 1 over A is the value to which you would go to the left. To get the same amount of area you would get going 2A from, to the right. Does that make sense? That is a multiple choice question that is almost asked at the level of difficulty of a free response question. You know what I mean? That took me a minute to remember what they were asking